is limit laws. What can we do to make this easier? And we are actually probably going to be on this section probably all next week. We have a 4-day week next week, so we're going to spend quite a bit of time on this and provide a lot of practice for it. So first, we're just going to go through some of these rules. All right, this looks terrifying, but we can read it. So the limit as x approaches a, so as x is getting to a number, of f of x, and the limit as x approaches a of g of x. Both of those exist. That means we're getting an answer when we plug them in. They do not exist. So it says the limit as x approaches a of f of x plus g of x is the limit equal to the limit as x approaches a of f of x plus the limit as x approaches a of g of x. What is that even saying? It's saying if I want to do the limits of two things added together, I can do their individual limits and then add them. Okay, the same is true for subtracting. You could do the individual limits and subtract them. Same is true if we are multiplying, which is actually number 4. You can do individual limits and multiply. The third one says c times f of x, that's a constant. So if you have a constant times something, so for instance, if I want to do the limit as x approaches 3 of 5x squared. So I could make that table for 5x squared, or what I could do is take the limit for x squared, get that answer, and then take it times 5. So constants can be pulled out. That's no big deal. Same, if we are dividing, we can do individual limits on top and bottom, assuming that the limit of the denominator isn't 0. Because why? It would be undefined. You can't divide by 0. All right, using that information, let's look at this one. So if I want, I'm pretty, the limit as x approaches negative 2 of f of x plus 5g of x. Okay, that's kind of complicated, but based on the limit laws, it says we can do the individual limits. So I could do the limit as x approaches negative 2 of f of x. And I could do the limit of this one, but what would I do with my 5? All right. So, as you approach negative 2 on function f, f is our pink one. So as we are approaching negative 2, what y value is that going towards? 1. Because we don't care what happens at the point, just as we are approaching. Okay, plus 5 times. As I'm approaching negative 2 on function g, from both sides, what's that one going to? So we have 1 plus 5 times negative 1. 1 minus 5 is negative. How would I do b? I have to do the limit of f, multiply that with the limit of g. All right, we've already said it's not negative 2 this time, is it? It's 1. Write that down correctly. All right, so on function f, as my x is getting closer to 1, what's our y approaching? 2. On g, as my x is approaching 1, what's my y? We can't do that because they don't match up. So if one of them doesn't work, what do you think the whole thing becomes? Yeah, it's undefined or it does not exist. Because the function of g doesn't exist there, so we can't do the overall. All right, You guys try C. What is limit as x approaches 2 of f? No, 1.5, 1.4, maybe even. It's not exact, so something thereabouts. As you approach 2, what's function g? 0. Can we divide by 0? No, so what happens? Okay. So, in order for us to use those rules, that both pieces have to exist, and we have to make sure we're not dividing by 0. But we can use our limit laws to calculate more complex expressions than we were doing previously. All right, any questions there? So, there are more laws. If you have the limit of something being raised to a power, you can do your limit first and take that answer to the power. So when I had the limit of x squared, what I could do is find the limit of x, get my answer, and then square it. The limit of a constant is a constant. Here's what that's saying. If I wanted the limit as x approached 0 of negative 2. Think about a graph. This is my function, so that's like y equals negative 2. What's y equals negative 2? Yeah. Horizontal line at negative 2. Here's y equals negative 2. No matter where I'm at then, if I'm, in this case, I'm approaching 0, my y is negative 2. But that's true no matter where you're at on that line. It's a flat line. So if you have the limit of a constant, it's always just equal to the constant. But, number 8, this is our nicest result ever. The limit as x approaches a of x is equal to a. Here's what that is saying. I want the limit as x approaches 1 of x. Okay, this is my function. X. That's like y equals x. What does y equals x look like?
Oh, it's a 1 to 1.
So, yeah, a line with a y-intercept of 0, slope of 1, so it has 0.00. 1, 1. 2, 2. Negative 1, negative 1. You can keep going all day. So it looks like this. It's the identity function. So as I am approaching 1, what's my y approaching? 1. And if I were approaching 2, my y would be approaching 2. If I were approaching negative 1, my y would be approaching negative 1. So this tells us if we can take an expression and get it down to just x, we know what that evaluates to. So in other words, if I said the limit as x approaches 3 of x squared. Okay, my limit laws say I could do the limit of the inside and then square that answer, right? What's the limit as x approaches 3 of x? 3. So this is 3 squared, which is none. And I just saved myself from creating 2 tables to try to calculate that limit. So this is kind of an extension of that. It's saying you don't have to show that much work. If you have x to a power, you can just plug it in. It'll be a to that power. So if I said the limit as x approaches 5 of x to the third, can you tell me what that would equal? 125. It would just be 5 to the third power. All right, last two. If you have radicals, you can you can do the same thing. You can still just plug it in under the radical, assuming that a is positive if your n is even. So remember, if you have an even index, so a square root, fourth root, sixth root, it has to be a positive number underneath there. And that is true if you have a more complex expression under there. So if I had like x cubed plus 3x squared plus 4. I could do the limit of that inside and then take the radical afterwards. So all of these rules are setting me up to be able to evaluate limits without making these tables. All right, so let's take a look at a couple. If I want to evaluate limits and justify each step, I'm not going to make you like write a proof and tell me this was limit ball number or whatever. But I want to kind of break it up to show what we are doing. All right, if I wanted to evaluate this without making a table, if I have the limits of things being added or subtracted, what would we do? We do the limit of each. Now, am I going to require this much work on every problem? Absolutely not. But while we're kind of learning the process, I want to do it on just a couple to show you how these laws work. Okay, I'm not ready where I can just plug in yet. But what would I do on this first one? What would you do with your 2? So it's 2 times the limit as x approaches 5 of x squared. Minus this one, the 3 could come out. So 3 times the limit as x approaches 5 of x. Plus limit as x approaches 5 of 4. All right. From here, we can plug in because we have this rule that says if you have the limit as x approaches a number of x to a power, you can evaluate that. So I have 2 times 5 squared minus 3 times 5 plus, what's the limit as x approaches 5 of 4? What's the limit of a constant?
4.
4. So we get 50 minus 15 plus 4. So 39. No table required. Does that mean we can always just plug our x in? No. But if the rules allow us, then we can. So that's why on these first couple I'm kind of showing you all the rules, and that's why we're allowed to just plug in. All right. So for B, we know that if we have a division problem, we can do the limit of the top and the bottom. Can I go ahead and take this to each one as well? So the limit is x approaches -2 of x cubed plus, what would I have to do with the 2 on this one? So 2 times the limit as x approaches -2 of x squared minus limit as x approaches -2 of 1. In the bottom we have the limit as x approaches -2 of 5 minus 3 times limit as x approaches -2 of x. Looks a little complicated, but we're ready to plug in. Because if we have x to a power, we can plug it in. So we have -2 cubed plus 2 times -2 squared minus, what's the limit as x approaches -2 of 1? Limit of a constant.
This is,
What's the limit as x approaches -2 of 5? Just 5. Minus 3 times the limit as x approaches -2 of x. We can plug it. So -8 plus 8 minus 1 over 5 plus 6. Any questions on this? So that was a lot of work for us to just end up plugging things in. And we do now have a shortcut for that after we verified this a couple times. If you have a polynomial or a rational function, which rational function is just 2 polynomials being divided, then you are allowed to just plug in your number, as long as it's in the domain. So if I'm getting 0 on the bottom, I can't just plug it in. But as long as I don't get 0 on the bottom, I can. So that will be true for any polynomial. And, okay, why don't I go ahead and stop there today? I know we have a little bit of time, but the next